In activity 37, we're going to be looking at taking some of the three-dimensional shapes that we're with. In this case, we're looking at specifically cubes and spheres. And then in 30, what's the next one? 37 dash 2. We're going to look at pyramids and cylinders, but we're looking at all of these different shapes in order to fill out this. This is our goal, to learn how, when we're comparing similar solids, do we actually, and we change the dimensions. Similar solids means that they're same shape, but they're different sizes. Is there, and we know the perimeter or the area or the volume of one, do we actually have to calculate the perimeter or the area or the volume of the other one, or is there some shortcut to being able to get that information? And that's what we're trying to figure out. We're going to fill this out. Where is this? Page 544. When we're finished with these few examples, filling this out, this is going to be like the formula that you have to memorize. Okay, so we're back here looking at these cubes. We're going to make a keychain, a cube keychain, a cube paperweight, and a cube planter. This one is 1 inch by 1 inch by 1 inch, and they want us to find all of these pieces of information. I've already written the formulas up here. I've already kind of given you a picture. The pink stuff down here at the bottom is the area of the base. That's what this is right here. It's highlighted in pink, the area of the base. I've given you the formulas up here. For the area of the base, you multiply the base times the height of just the base. Don't get this height confused with this height. This is the height of just the base. This is the height of the cube. This is the height of the cube. So anyway, you should be able to fill out this chart. So stop the video and see if you can't get this chart filled out. Okay, so you should have had these calculations. You can't always trust me that I'm 100% correct. So if you get something a little bit different, and you can see why we might have something different, then it's okay to be different than me, because I make silly mistakes all the time. But I tried very hard to make sure I didn't make any mistakes. So I put the formula. Surface area is the perimeter of the base times the height of the prism plus 2 times the area of the bases. I tried to show my work. I found the area of the base on each one of these. 1 times 1 is 1, 3 times 3 is 9, 9 times 9 is 81. I found the perimeter. 1 times 4 is 4, 3 times 4 is 12, 9 times 4 is 36, and then I simply plugged those numbers in. This capital B, remember, is the area of the base. So the area of the base, 1 times 1 times 1 is 1, 3 times 3 times 3 is 27, 9 times 9 times 9 is 729. So these are the numbers that I got: 1, 9, 81 for the area of the keychain, the paperwork, the planter. 654 and 486 is the surface area that I got for each one of them. And then there's the volume. And now it says conjecture. You know what conjecture means? It means we're going to make an observation. We're going to observe something, and then we're going to guess about that observation to see if we can discover a rule. Make a conjecture about how the surface area changes when the edge of the cube is tripled. So here's what they're talking about. So I'm going from this to this. That's tripled. It was 1, now it's 3. 1 times 3 means triple. Okay, and they want us to look at the surface area. Okay, how did that change? So we tripled it, and it went from 6 to 54. So can you see a conjecture about tripling it that will allow you to make a guess about a different measurement, not just tripling? So since we're talking about tripling and that implies multiplication, in other words, they're asking us this. If we take the base edge and we multiply it times the original base edge, which was 1, we multiply it times 3, what should we do to the surface area? Okay, so the surface area of the first one was 6. The surface area of the second one is 54. So 6 times what? Gives me 54. That's, I think, what they're trying to say. Okay, and of course we know that 6 times 9 gives me 54. So 9 times the area, if we change the edge by tripling it, then it's going to change the area. The area is going to change by times 9. Okay, it says use your conjecture and this information from the table to predict the surface area of a cube whose edge is 27. Okay, so if we look at this one, if we go from this one that's 9, if we consider that one as our original one, and we multiply 9 times 3, that's tripling it, we get a new edge that's 27. So that should mean that we should be able to take this surface area right here, which is 486, and multiply that by, what's our prediction? Times 9. 486 times 9. 486 times 9. My calculator tells me that is 4,374. Now, we did that by using this conjecture that we come up right here, but can we real quickly calculate the surface area of a cube that's 27 by 27 by 27? And the formula is we need the area of the base. The area of the base is 27 times 27. That's 729. We need the perimeter. The perimeter is 27 times 4. So that's 108. And the surface area, if we calculated it, would be the perimeter, 108, times the height of the cube, which is 27, plus 2 times the area of the base. Okay, and remember, we've predicted that that answer right there is going to be 4,374. So I'm going to type this information in my calculator, 108 times 27 plus 2 times 729, and guess what my calculator tells me? 4,374. So would you rather have to work it out by hand like we did right here, or would you rather use this little formula that we just made out of a conjecture, something that we've noticed? If we have a shape, we triple its measurements, then the area is going to be 9 times bigger. Now, we're eventually going to, because we're not always going to triple. What if we double it? What if we multiply it times 5? What it has a scale factor, it's 5 times bigger. There is a relationship between how the perimeter changes or how this length changes. This one was times 3, we tripled it, and this one right here was times 9. There is a relationship between these two. So if we don't triple it, if we make it times 5, what's this one going to be times bigger? That's what we're trying to figure out now. So they want us to go ahead and make a conjecture about the volume of the cube, the volume, okay? And we went from, we tripled the edge, and the volume changed from the first one right here, the volume was 1, and then the volume was 27. So by multiplying the cube times and making the edge go from 1 to 3, that's 1 times 3. What did we do right here? It became 27 times bigger. So they said, now let's make the conjecture. Use your conjecture from this information to predict the volume of a cube who's 27. So we're going to go back up here and work it again in just a second. But right now, according to this conjecture, if we do the volume of this cube, 729. 729. And we multiply that times 27, we will get the new volume, which is 729 times 27. We get a new volume of 19683. Whoops, my one, it was way over there. 19683. If we go over here and find the volume using the formula, we do 27 times 27 times 27, and 27 cubed is, guess what? 19683. And again, there is a relationship between tripling, I don't see the word triple, but if I triple the edge, my volume changes by 27. There is a connection between those two, and that's what we're going to discover.